So we're Team 30 and we're doing the General Dynamics project. The problem we're trying to solve is we're trying to see if Rust is adequate for national defense software. The main problems we're trying to figure out is if Rust is a sufficient programming language for the demands required of General Dynamics, and we are trying to see the trade-offs of C++ versus Rust and how the performance and efficiency differ, and then use this knowledge so that General Dynamics can make more informed decisions on which software they would want to use.
Hello, my name is Ross Potter, and our project goal will be designing, testing, and implementing both C++ and Rust onto an NXP reference board to set up a system that will showcase the differences between the two languages from both speed and memory. The project scope aims to explore the performance and efficiency differences in a real-time environment and virtual environment. The project will use these virtual and real-time environments, mainly with the real-time environment on an NXP LS1046 reference board to run the various tests and variables utilizing input and output sensors for a measurable and general understanding of round-trip latency.
Hi, my name's Hunter. The consensus population benefits. If we showcase the benefits of Rust as a primary programming language for embedded processing systems, we can have fewer security vulnerabilities. Many cybersecurity issues come from self-built memory safety where Rust is built in. Proving Rust is faster than C++ would help us create faster processing systems, leading to better real-time decision-making military systems. Reducing cost. Due to the Rust enhanced error handler, making program errors explicit and predictable, this leads to a reduced cost and long-term maintenance. The consensus, success and challenges. Success for this project can be comprised of a showcase that is clear and obvious, showing that Rust is a dominant programming language when compared to C++. A few technical challenges that could arise would be as follows. Issues with setting up the NXP board, issues with running the Linux SDK or the compilers on the board, issues with input and output sensors. We'll be going through various communication protocols, so we have to do our due diligence to confirm everything is working properly. The issue is displaying the actual differences between the computing languages. Some of the areas we will be focusing on may not have obvious differences, so we may need to scale/shift differences to make them receivable from an audience perspective.
Hi, my name is Elvis, and we have divided the project accordingly for everybody to have a requirement of what they need to keep track of. And so Pranav is helping us with the board setup and initial code and writing, and he's our only member on site, but we can also access the board through AWS accounts that has been set up for all of us. So our plan is to test sensors and communication protocols, and part of what I'm going to help with is with the part selection and integration. And Ross already has some experience working with Rust, and he can help us with the knowledge gap if we ever need it. And Hunter is helping us with the documentation and keeping track of the progress of the project and any assignments that we need to submit. We also plan to test at least one sensor by the end of the semester. We have like a timeline to keep track of our goals and what to do each week. And in conclusion, our target is to explore the feasibility of Rust as a programming language. We're finding we highlight Rust advantages in memory serve and security, and this is where we contribute to the understanding of Rust in critical infrastructure and further exploration in this field is going to be probably necessary in mission critical systems.